All right, AP Stats, happy asynchronous Wednesday. Don't you just love when your teachers give you assignments that you haven't gone over and you have no idea how to do? I'm really sorry about the 2 Khan Academy assignments. I deleted one of them and I made the other one extra credit. That won't happen again. I will be sure to complete the Khan Academy before I assign it to you to make sure that it's what we went over in class. So I apologize about that. I'm going to go ahead and go over that interpreting two-way tables Khan Academy. So I have 2 of the Khan Academy problems to review with you. And then once you watch this video, we have a 4-question exit ticket with AP practice questions. All right, so the two-way row relative frequencies below shows data on nationality and eye color. All right, so the difference between this and what we did in class is that this has relative frequencies instead of frequencies. It's got proportions instead of actual counts. That's the only difference. So what you need to know is that the rows sum up to 1 instead of the columns. So what we did was we had a sample of English, a sample of German, and a sample of Italian. We did not have a sample of brown-eyed people, we did not have a sample of blue or green-eyed, and we did not have a sample of other. These were the samples we took, right? These sum up to 1. All right, so before we start anything, I'm just going to make up some sample sizes, and we're going to calculate how many each of them were. So let's just say that the English sample size, and when I say sample size, I mean the number of people that we sent the survey to. We'll say the English sample size is 100 people. We'll say the German sample size was 200 people. And we'll say the Italian sample size is 300 people. The abbreviation for sample size is N in statistics. So what I would say here is that N is equal to 100, N is equal to 200, and N is equal to 300. I just made these numbers up. They're not related to the problem. I just want to walk through translating how I would get the actual counts here. I just made these up. They're not part of the problem. All right, so looking at this, if I have 100 people, and let me pause the video, I'm going to rewrite this chart on my paper. We're going to turn this relative frequency count table into a frequency count table with the actual numbers. So starting off, if the number of English people that I surveyed was 100, then to get each specific category, I'm just going to multiply the proportion by 100. So I'm going to do 100 times 0.48. That's going to give me 48. I'm going to do 100 times 0.5. It's going to give me 50. And then 100 times 0.02, and that's going to give me 2. When I add these numbers up, they should sum up to 100, my sample size that I made up. 100. All right, so same thing with German. If my sample size of Germans were 200, to get each specific category, I'm going to multiply the sample size by the proportion. So 200 times 0.47 is 94. 200 times 0.52 is 104. And 200 times 0.01 is 2. When I add all these up, I should get my sample size of 200. So 94 plus 104 plus 2 gives me 200. All right, then my last one, if I had a sample size of 300 for Italian, I'm just going to multiply 300 times the first proportion, 0.8. That gives me 240. I'm going to multiply 300 times 0.18. That's going to give me 54. And then I'm going to do 300 times 0.02, and that's going to give me 6. When I add them all up, I should get 300. So 240 plus 54 plus 6 is 300. So I don't actually know the counts unless they give me the sample size. So with relative frequency tables where I just have the proportions, I don't actually know the true counts of each category of people unless they give me the sample size. But I do know that out of my English sample size, this was my proportion, right? Whatever the sample size was, I know that 48% had brown or hazel eyes, 50% had blue or green, and 2% had other. But I don't know the actual counts unless they give me the sample size, and then once I have the sample size, I just multiply by the proportions to get the true number. All right, so based on the data, which of the following statements must be true? What I want you to do is just forget that I made up sample sizes. We don't know the sample size. I just wanted to show you how to do that because I believe one of your multiple choice questions is involves multiplying the sample size by the relative frequencies. All right, based on the data, which of the following statements must be true? All right, A says there are the same number of English people and Italian people with other eye colors. Same number? I can't say anything about numbers because I don't know the sample sizes. I only know the proportions within each group. So I don't know if A is true or not. It could be, it could not be. We don't have enough information. We're talking about same number of people, and we don't have the sample sizes. We only have the proportions. All right, B. Italians are more likely to have brown or hazel eyes than Germans are. All right, so let's look at our Italian. Italian is 0.8, and then German is 0.47. So this could be true. All right, C. Because if you're Italian, you have an 80% chance of having brown or hazel eyes, and if you're German, you have a 47% chance. So 0.8 is greater than 0.47. So I would say that Italians are more likely. All right, a German person is more likely to have brown or hazel eyes than blue or green eyes. So this is saying that brown would be greater than blue for Germans. Let's look at just the German row. 0.47, 0.52. 0.47 is not greater than 0.52, so this is definitely not true. A German person is more likely to have blue or green eyes. All right, and then D, this one was the confusing one. So D, a person with brown or hazel eyes is least likely to be German. So you're looking at this column right here. A person with brown or hazel eyes is least likely to be German. Well, you see that German has the smallest percentage, so at first you think that's true. But remember, our groups of people are how we did our samples. See how each row sums to 1? I didn't get a group of brown or hazel-eyed people and ask them what nationality they were. So I cannot compare these proportions because this was not my sample size group. My sample size was the rows, the nationality. So I can't say anything about this because I don't have a count of brown or hazel-eyed people. It all depends on the sample size. So D is not true. I can only make judgments based on the rows, not the columns, because my rows sum up to 1. If I had the sample sizes, I would be able to figure that out because I'd be able to actually have the counts of brown or hazel-eyed people. But since I only have the relative frequencies, that won't work. So B was my answer here. All right. Number 2, a survey asked students at Wilson Academy which status they would prefer, to be happy, healthy, or rich. I know which one I would want to be. And how much pressure they felt from homework. A two-way table row of relative frequencies, so when you see this, you should automatically think proportion or percentages, not actual counts. We don't have the actual counts of people. Okay, and it looks like we did our samples based on rows because those rows sum up to be 1. So I can't do any comparison of the columns, right, because my samples were only with the rows. I took the happy people, broke them out. I took the healthy people, broke them out, and I took the rich people and broke them out. I cannot make judgments about columns because they don't sum up to 1. So I cannot compare them without sample sizes or like the actual counts, the frequency counts. All right, so based on the data, which of the following statements about students at Wilson Academy must be true? All right, so number 1, a student who prefers to be healthy, which is a row, so I can do some comparison because it's a row. A student who prefers to be healthy is more likely to feel very little pressure from homework than a student who prefers to be rich. So very little would be 0.15, and from a 0.05. Alright, so a student who prefers to be healthy, which is the middle row, is more likely to feel very little pressure than a student who prefers to be rich. So more likely to feel very little pressure. 0.15 is more likely than 0.05. So I would say this one is true. We'll come back to it, and let's eliminate the others. Alright, B, a student who prefers to be happy is more likely to feel very little pressure than a lot of pressure from homework. Alright, so this one we're just looking at one row specifically. And the row that we're looking at is the happy row at the top. Alright, a student who prefers to be happy is more likely to feel very little pressure. So my very little should be bigger than my lot. So let's see, my very little is 0.13. Is that bigger than my lot, which is 0.46? No, it's not. So this is not true. Alright. C. A person who feels some pressure from homework is most likely to prefer to be rich. A person who feels some pressure from homework. So it's asking for a comparison among the column, and we can't do that. It doesn't sum up to 1. We didn't survey people based on the pressure from homework. We surveyed people on their life preference. So I cannot make any assumptions from the sum column because I don't have the counts. Alright, D, an equal number of students who feel a lot of pressure from homework prefer to be happy as prefer to be healthy. Well, I know that this can't be true because it says number of students. I don't know the sample size count, so I can't say anything about the number of students. They might have the same proportion, so like looking at this, homework prefer to be happy and healthy. You see how they have the same percentages, 0.46? But what if this sample size was 100 and this sample size was 200? 100 times 0.46 gives me 46. 200 times 0.46, gives me 92. So if I have different sample sizes, I could have different numbers. So I can't say anything about the actual count, the frequency or numbers, because I don't have the sample sizes. It doesn't tell us how many students we interviewed within each category. So A is my correct answer. Alright, number 3 is actually a sample AP problem from College Board. So a market researcher asked a group of men and women to choose their favorite color design from a sample of advertisements. The results are shown below. The first thing that you should notice is that this is a frequency table instead of a relative frequency table. How do I know it's a frequency table? It's got counts in it instead of percentages or proportions. So you see how I have the actual counts of men and women, so I know the sample size. Alright, which of the following statements is not supported by the table? So that word not is important because that means 4 of these should be supported by the table and 1 of them is not. Alright, A, more men than women chose the color design red with black. Alright, so let's look at the red with black. It's right here. More men than women. Men was 21, women was 15. So that's true. Alright, let's look at the next one. More women than men chose the color design yellow with black. Here's yellow with black. More women chose than men, right? 11 is bigger than 8. So that's true as well. Alright, C. For men, the number who chose a design with black was greater than the number who chose a design with blue. Alright, so now that means we're just going to look at the men row. Alright, so it says 4 men. Oh my gosh, I hope this was not out of focus the whole time. Okay. 4 men, the number who chose a design with black was greater than the number who chose a design with blue. So let's just add up the designs with black. So with black is going to be 21 plus 15 plus 8. All right, and then with blue is going to be 12 plus 35 plus 9. So let's add these numbers up and see which one's bigger. 21 plus 15 plus 8 gives me 44. And then 12 plus 35 plus 9 gives me 56. So more men chose blue. It says here the number who chose a design with black was greater. So C is what's not supported. C is my answer. But let's keep going and eliminate D and E as well. All right, so D, the color design chosen by most people was green with blue. All right, so that means we need to total up all the columns and see which one has the highest number. All right, that should be pretty quick. 21 plus 15 is 36. 15 plus 3 is 18. 8 plus 11 is 19. 12 plus 31 is 43. 35 plus 24 is 59. And then 9 plus 16 is 25. So it looks like my biggest one is 59, green with blue, and that is what most people chose, so this is true. All right, and then E, the total number of men surveyed by the market researcher was equal to the total number of women surveyed by the market researcher. So I just need to sum up my rows to see how many men were surveyed and how many women. So my men, 21 plus 15 plus 8 plus 12 plus 35 plus 9. So that gives me 100 men surveyed. Women, 15 plus 3 plus 11 plus 31 plus 24 plus 16. So I had the same number, 100 and 100. So E is also true. So you see, when we actually have a frequency table instead of a relative frequency table, it's a lot easier to deal with. That's when we have these counts instead of the proportions. All right, and then the very last one. All right, college researchers wanted to know under what conditions people are more likely to complete and return a survey. As part of the study, researchers prepared 3 sets of identical surveys and used 3 methods of delivering and returning the surveys. Here are the methods. So we have in class. Surveys were given in class. Students were asked to return their completed surveys to their instructor. Psychology. Surveys were given to students participating in the psychology experiment and were asked to complete the surveys to a collection box in the hallway. Or dining hall. Surveys were given to students in the dining hall and students were asked to return them completed to a collection box outside. The graph below shows the percent of surveys, so not count. So we are dealing with relative frequency, not frequency. Remember, relative frequency is percent or proportion. Frequency is actual count. So I don't know how many students received the in-class survey, the psychology survey, or the dining hall survey. It could all be the same number, or it could be different numbers. We don't know. All we have are the percentages. So it looks like the light gray is return the survey, the dark gray is did not return the survey. All right, so what statement about the delivery method and rate of surveys supported by the graph? All right, A, there's a positive association between delivery method and rate of return. So go ahead and eliminate A and B because we haven't learned about associations yet. So if there is an answer choice on one of your multiple choice questions, I promise you I read through them. So if there's an answer choice that we haven't gone over yet, you can eliminate it because I'm not going to give you a question on something we haven't discussed yet unless it's Khan Academy. Sorry about that. That won't happen again. All right, so let's look at C, D, and E. The number of surveys given, well, this is already making me skeptical because it says number, and I don't know anything about the numbers. So the number of surveys given using the dining hall delivery method was less than the number given using either of the other surveys. We have no idea what the numbers are. So let's eliminate C. D says the psychology delivery method displays the most symmetric results, and the other delivery methods display skewed results. Learned anything about symmetric or skewed? Eliminate D. All right, E, the in-class delivery method that had in-class delivery method had the greatest rate of return, and the dining hall had the least rate of return. All right, so rate of return would be the light gray. So it looks like my dining hall rate of return is maybe about 35, and my psychology is about 50, and my in-class is about 55. So according to the chart, the in-class method did have the greatest rate of return. It's about 55, and the dining hall did have the least. So E is my correct answer. All right, don't get frustrated by answer choices that you don't know. So the AP exam is going to throw every single thing that we've learned the entire year in its answer choices. So I want to start exposing you to these AP multiple choice questions, but it's hard to do that when some of the answer choices are things that we haven't gone over yet. So just know if I'm giving you a multiple choice question that's AP practice, you are able to do it and to just eliminate anything that that you haven't learned yet. All right, so go ahead and click the link on the assignment to go to the 4-question exit ticket.